Welcome back, everybody, to lesson 4.1. Today we will be defining quadratics. So this will be the beginning of our quadratics unit. I just want to let you guys know at the beginning of this video, I think that I've gotten away a little bit from just putting just the facts and information that you need in the videos. So I'm going to get back to the basics. These videos will be shorter and we'll just be giving you the facts and information that you need to know coming into class. So when you're watching these videos, take down all of the facts and information out of the videos and just watch the few small examples, and we'll go through some more in-depth examples in class. So let's get cooking defining quadratics. So a quadratic is a second degree polynomial. So what a polynomial is a collection of terms with your variable raised to a natural number power. Basically what that means is quadratics will look like this: ax squared plus bx plus c. And the degree, I said it's a second degree polynomial. The degree is the largest power of a term in a polynomial. So right here says this is x squared, this is x to the second power. This is a second degree polynomial. So any second degree polynomial is a quadratic function. And the way that I'm going to refer to these terms, this term ax squared, this is the quadratic term because that's the term that's raised to the second power. The second term, the bx, this is the linear term because it's just x to the first power. That's a linear term. And then the third term is what's called the constant because it's just a constant. There is no variable attached to it. So quadratic function is the second degree polynomial written as ax squared plus bx plus c in standard form. So this form right here is what's called standard form. And then I refer to this first term as the quadratic term, the linear term, and then this term is the constant. All right, so the graph of a quadratic is called a parabola. So you may have seen parabolas before. So we're going to do this in class, but for this equation, we're going to use the chart to plot the points and graph the function. Basically, this isn't what the parabola is actually going to look like, but a parabola is going to look kind of like a U shape that'll open either up or down for the purposes of the ones that we're going to look at. So we're going to plot this in class to see what this looks like. So these are a couple characteristics of parabolas that you need to know for our class. So one is that parabolas for our class open either up or down. All right, so the parabolas open either up or down. We can determine which direction the parabola will open by looking at the value of a in standard form. So you know how we have ax squared plus bx plus c. If a is positive, this parabola will open up. If a is negative, the parabola will open down. The second thing, parabolas are symmetric. So what that means is for every parabola, so if we go back and just take a look at this one that I drew here really quickly, let's pretend like that's symmetric. There's what's called an axis of symmetry that goes through this point, which is called the vertex of the parabola. I know I'm giving you a lot of words right now. We're going to go through all of these in depth when we get to analyzing parabolas, but in general, we need to understand the parabolas that we look at. There is an axis of symmetry that will always be a vertical line. Because ours are always opening up or down, the equation of the axis of symmetry will always, I should say equation, not equation. So the equation of the axis of symmetry will always be a vertical line, and we can find the equation by looking at this equation in standard form, and the equation of the axis of symmetry will be x equals negative b over 2a. All right, so this is ax squared plus bx plus c. The axis of symmetry would be negative b over 2a. And that would be the axis of symmetry. All right, so really quickly, we're going to run through this problem. So like I said, we're going to have some short examples. Really quickly, we're going to look at this one. Which direction does the parabola open? This is positive, so it opens up. Because the a value here is positive 5, this parabola will open up. So the equation of the axis of symmetry, this will be x equals negative b over 2a. In this case, a is 5. B would be negative 9. Make sure you pay attention to the signs. And then C would be 11. So this is going to be 9 over 2 times 5, which is 9/10. So the equation of the axis of symmetry would be x equals 9/10. All right. So this form right here, I'm going to show you a couple of these different forms, and we'll go back and forth between this form and standard form in class. But this form right here is called factored form. Factored form is when I write the quadratic as the product of two linear factors. In lesson 4.3, we're going to learn how to take quadratics in standard form and write them in factored form if possible. It's not always possible, but if possible, we're going to learn how to factor quadratics and write them in factored form. All right, so we're going to do this in class. I'll go ahead and tell you because I kind of gave this away. This is a quadratic. And to write the function in standard form, basically what we're going to have to do is just multiply. We're going to have to multiply these two terms together and it'll give us a quadratic in standard form. All right, so this form is called vertex form. So you notice this form is a little different from the previous one because this is what's called vertex form. I use this to help me graph quadratics. In lesson 4.4, we're going to learn how to convert between vertex and factored form, vertex and standard form. I should say vertex and standard form. So in lesson 4.4, we learn how to convert between vertex and standard form. And in lesson 4.4, we're also going to learn how to use vertex form to graph quadratics. So I just want you to see these different forms so that you're familiar with them. And then this we will also do in class. So if you want to, you can take a look at this problem and go ahead and start thinking about it. So this is going to use some of those properties of quadratics that we know. And we're going to use this information to write an equation for this quadratic in standard form. So that is it for today's lesson. Today we talked about defining quadratics and some properties of parabolas. Oh, God bless me. And we also just took a look at a couple different forms of quadratics. So if you have any questions, make sure that you bring them to class. I hope you took some good notes and you've got the facts down, and I will see you in the next video. Have a great day.